Water pollution occurs when harmful substances, often chemical or organization, contaminated a stream, river, lake, ocean, aquifer, or other body of water, degrading water quality and rendering it toxic to human or the environment. This widespread problem of water pollution is jeopardizing our health. Unsafe water kills more people each year than war, all other forms of violence combined. Meanwhile, our drinkable water sources are finite. Less than 1% of the Earth's fresh water is actually accessible to us. Without action, the challenge will only increase by 2050, when global demand for fresh water is expected to be 1/3 greater than it is now. The first factor of water pollution is sewage and wastewater. Harmful chemicals, bacteria, and pathogens can be found in sewage and wastewater even when it's been treated. Sewage and wastewater from each household is released into the sea with fresh water. The pathogens and bacteria found in the wastewater breed disease and therefore are the cause of health-related issues in humans and animals alike.
So the second factor of water pollution is radioactive waste. Radioactive waste from facilities that create nuclear energy can be extremely hazardous to the environment and must be disposed of properly. This is because uranium, the element used in the creation of nuclear energy, is a highly toxic chemical. Unfortunately, accidents still occur at these facilities and toxic waste is released into the environment. The coal and gas industries are, in many ways, no better. This is one of the major impetuses behind the development of alternative, clean sources of energy, including solar and wind. The third factor of water pollution is oil leaks and spills. The age-old phrase like water and oil is used when describing two things that do not mix easily or at all. Just as the saying states, water and oil do not mix and oil does not dissolve in water. Large oil spills and oil leaks, while often accidental, are a major cause of water pollution. Leaks and spills often are caused by oil drilling operation in the ocean or ships that transport oil wildlife.
The experiments that we can do for the water pollution is pH test experiments. Here's the detailed procedure for the pH levels and water pollution experiment. Objective is to observe how different substances affect the pH levels of water and understand the impact of chemical pollution. The materials that we need is, first, we need a clean water, and second, we need a pH test strips or a pH meter. Third is lemon juice as acid and baking soda, and fourth is baking soda as a base. Clear containers 3 to 4 small cups or glasses and a spoon for mixing. Step first is to test the pH of clean water. First, fill the first container with clean water. Second, use a pH strip or meter to measure the pH of the water. Third, record the pH value. Typically, clean water should have a pH close to 7. Step 2 is to simulate acidic pollution. First, we need to fill the second container with the same amount of clean water. Second is to add a few drops of lemon juice and stir well. Third is test the pH using a strip or meter and record the value. Fourth is observe how the addition of lemon juice makes the water more acidic, lower pH. Step 3 is to simulate alkaline pollution. First, fill the third container with clean water. Second, add a small amount, about 1 per 4 teaspoon of baking soda and stir well. Third is test the pH using a strip or meter and record the value. Fourth is observe how the addition of baking soda makes the water more basic, higher pH. Step 4 is to mix acidic and basic pollutants. First, fill a fourth container with clean water. Second, add both lemon juice and baking soda to the water. Third, stir the mixture well and test the pH. Fourth, record the pH and observe the interaction between acidic and basic substance. For the observations, clean water typically has a natural pH more than 7. Adding lemon juice lowers the pH acidic. Adding baking soda raises the pH that is basic. Combining acidic and basic substance can neutralize the pH depending on the amounts. The conclusion is, this experiment demonstrates how chemical pollutants can alter water's pH balance, affecting aquatic ecosystems. Extreme pH change can harm plants, animals, and microorganisms in the water.
2 solutions to avoid water pollution. First, stormwater management. Retention ponds. Capture and filter rainwater runoff before it reaches waterways. Permeable pavement. Allow water to seep into the ground, reducing runoff. Swales. Channel designed to slow down and filter stormwater. Rainwater harvesting system. Collect rainwater to reuse in irrigation. Second solution are design considerations. Green infrastructure. Incorporate green infrastructure elements like rain garden and bioswales to filter runoff. Natural drainage patterns. Mimic natural drainage pattern to reduce runoff velocity and sediment transport. Conclusion. In civil engineering, addressing water pollution is a critical responsibility to ensure sustainable development and environmental preservation. The conclusion highlights the importance of implementing effective water management strategies, advanced wastewater treatment technologies, and sustainable construction practice to mitigate the adverse impact of pollution on water bodies. By integrating innovative design, strict regulatory compliance, and community awareness, civil engineers can play a pivotal role in minimizing water pollution, protecting ecosystem, and ensuring access to clean and safe water for present and future generations.